the Virginia Tech Stability Wind Tunnel originally started out as the NACA Stability Wind Tunnel, and in about 1960 it was given to Virginia Tech, and it became a teaching and research facility for Virginia Tech. It's also become an internationally known aeroacoustic wind tunnel. That's made us very well known because this was an innovative change, and others are now copying it across the world. So we do a lot of work for industrial testing work, some for aircraft companies, some for wind energy companies, a lot of government-sponsored research, but most of all we're doing all this to bring this state-of-the-art capability to undergraduate students. One common thing we do with the tunnel is we try to integrate research projects and undergraduate education. Right now we're running a wind tunnel test that's for the US Navy. So we're researching new science for them, and that research is being led by 2 PhD students. And we've integrated this with undergraduate lab. So we want the undergraduates to be directly assisting in this federally sponsored research, and we're also integrated at the other end with NATO. So this is part of a NATO team effort that's coordinated across NATO to understand these kinds of flows. So we have essentially integration of this project from the level of the undergraduates all the way to NATO.
The project that I'm working on is a study of turbulent flows over rough surfaces and pressure gradient. So for the Navy, they're interested in making vehicles more quieter and efficient. And so these naturally occurring roughness, such as barnacles, can then result in a lot of noise. And so the purpose of our project is to understand, the effects of roughness, how we can better optimize and sort of understand what exactly roughness is doing to turbulent boundary layers and how that impacts the performance of a vehicle.
We are running one of the many experiments for AOE 3054 Junior Lab, which is a lab course that all aerospace and ocean engineering undergraduates take. And so they're going to spend 2 weeks here in the Stability Wind Tunnel. And while they're here with us virtually over Zoom, they're going to be taking measurements that are directly related to my PhD research. So they come in on a Zoom call, we give them a virtual tour of the facility, and then they get to be a part of the measurement taking process. And then we basically save out some data and send it to them over Google Drive, and they get to process some of the data from our experiment.
They're essentially taking their class as part of our research experiment, and the data that they're acquiring as part of their class is actually research quality data that we're using for our own dissertations and for our project.
One of the advantages of doing leading edge research and industrial testing is you get very much a sense of what the state of the art is. And to maintain those capabilities requires a lot of rebuilding stuff, a lot of resources, a lot of investment. So some recent upgrades would be, we've completely relined the contraction of the tunnel, and then the test section we rebuilt. We had the fan redone. We've got brand new instrumentation, laser-based instrumentation. An active scientific facility like this is the absolute antithesis of a museum. We keep nothing around because it looks pretty or because it costs a lot of money in the first place. We only keep things around that are useful, and then we clear stuff out and we bring in the next latest technology because that's what you have to do to stay ahead, and that's what we want to be giving our undergraduate and graduate students experience of.